Hi all, very good afternoon. Welcome back to the Java classes. So today we are going to learn about the next topic, that is abstract classes and methods. So here to start with, we are going to use a keyword called abstract with the classes as well as methods. So abstract class supports to enclose abstract methods, concrete methods, static methods, constructors, and general and static instance variables. Right. So when abstract class is created, it restricts the creation of object with a dynamic memory to it. For example, if I would like to say, if I create an object for any of the class like this, suppose I have a class called sample. So I'm going to create sample obj equals to new sample. Right. So here I can use a new keyword to create a dynamic memory allocation or to the object which I have created for this class. But if this class is of abstract type, then I can't create dynamic memory to it using new keyword. Is that point clear? So this is the meaning of this statement. Now, how I can create the object for that? So this is the syntax. Base class name object equals to new derived class name. So here base class is an abstract type. So if the base class is an abstract type, then I can't create object using new keyword for base class. That's the reason why I'm going to create here the derived class name. Right. Then that is one way of creating the object. And one more way of creating the object is base class name obj1 equals to obj. So what is this obj? It's an object which is created for derived class. Let us suppose I have a derived class, derived obj equals to new derived. So this derived class is not the abstract class. So I can create object with new keyword. Yes. Now, whatever the object I have created with the derived class, that object I'm referring to the object of your abstract class. So it's nothing but I'm sharing the memory of derived class object to the abstract class object. So abstract class is purely dependent on derived class. So when a class is enclosed with minimum of one abstract method, that class should be converted to abstract type. Is that point clear? If there are no abstract methods, no need to convert the class into abstract type. Right. Next point is we are going to work with the syntaxes. Okay. Through which abstract class and abstract methods are created. So this is the syntax for abstract class, where you're going to create abstract keyword with a class and a class name. And in that abstract class, you're going to include instance variables, constructors, concrete methods, right? Abstract methods, static and general instance variables. Everything is possible in terms of the abstract class. And you have a method. The syntax for method is generally we have public, which is access specifier, return type will be void, method name is some calc, let us suppose, and list of parameters. These are not mandate. List of parameters we can take or we may not take, right? Followed by semicolon. So in terms of your abstract method, only prototype should be specified, right? Whereas the definition of this prototype or this function should be defined at a derived class. Okay, let us see that with an example in coming slides. Now here we have an abstract keyword which is attached to it. So it is going to become an abstract method. Abstract access specifier, return type, method name, list of parameters. Okay. So now there are some points to be remembered to work with abstract class. What are those points? When abstract method is enclosed, only prototype should be specified. As I said, you're going to specify only the prototype, that is a function with semicolon, which is also called as a function call. Then what about its definition? Then that definition of that abstract class abstract method, okay, should be written at a derived class. So only function protocol or prototype or function call should be specified at base class, that is abstract class, whereas its definition should be derived at a derived class. So abstract method cannot be created with private access specifier, because since the private, you know that since the private of base class never gets inherited to your derived class. Is that point clear? So now abstract class cannot be created with an object of dynamic memory allocation that we have discussed, right? It can be created only with reference object. Is that point clear? That we have seen in the previous slide. You can see here, this is the way you're going to create a reference object, and you are not going to create the object with the dynamic memory allocation like this. Okay, so here it is derived class, so it is correct. Okay, whereas if you see take the base class name here also, and if that base class is an abstract, so it is again wrong to create dynamic memory to it using new keyword. Clear? So now this is also clear. Now we work with the example program, which consists of your abstract class as well as abstract method. So now you can see, generally we will take a class by name, class base, or any class name. But what I've done, I've attached a keyword called abstract. So this class have become now abstract class. Okay, and my abstract class name is base. And here I have taken public base is a constructor because the class name as well as constructor name are same. Okay. Now, in the first print, I'm just printing in the print statement message from default constructor of base class. Then I've created one more method called A. Okay. That A method, in that you're going to create a message from concrete method. Then you can see here, this is an abstract method. See, you'll get the difference between the normal method and abstract method. In normal method, you can see you're writing the function and you're writing the definition here itself. Is that point clear? Whereas for abstract method, just you are writing a function call or a prototype, but you're not defining the definition here. You're not writing anything, right? So this is abstract method, abstract public void B, right? So this I'm going to remove because already it is there. You can see here, derived class extends base. So from here you have done with your base class. Now base class consists of base class constructor, A method as well as B method, two methods, right? And the derived class extends base class, that is abstract class, right? Base is abstract class. And in this, you have created a constructor public derived, okay? And you have written default constructor of derived class, the message. Then whatever the abstract method you have created in base class, you're going to define here public void B with abstract method of base. And afterwards, there's a C method, which is a method for your derived class. So you're printing message from C method of derived. Is that point clear? So now base class consists of default constructor of base, A method, B method. And derived class consists of derived constructor, B method, C method, and as this derived class is extending your base, it also consists of A method. What all the things present in base, those things will be present in derived. Is that point clear? Now, you're going to create a main class, class abstract, main. Now you can see you have created object to derived class. See, derived class is not an abstract class. So you can create an object with dynamic memory allocation. Derived obj equals to new derived, right? So you can create that using new keyword. Now, derived class consists of, you can see as derived class is extending your base class, it consists of A method, okay? It consists of B method, it consists of C method. So you can see obj, as you're creating object for derived class, obj consists of all these three methods. Obj, which consists of A method, B method, as well as C method. Right. So now, whenever you create object, constructor gets called automatically. So constructor goes to your derived class constructor. From there, as it is, this derived class is extending your base class, right? So it will check whether any constructor is present at your base class. So yes, constructor is there. So it comes to this constructor. First, it prints message from default constructor of base. First, it prints this one. Okay, then afterwards it is going to print this one, right? What is that? That is default from the default constructor of derived. Okay, once that is done, it comes to A method, obj.a. So it goes to A method, message from concrete method will be printed. Okay, then afterwards obj.b, cursor comes to prototype. Okay. So yes, here it is a function call. It will check whether its derivation is present at derived class or not. Whether its definition is present at derived class or not. Yes, it goes to this point. Yes, definition is present. Abstract method of base will be printed. Okay, and afterwards, obj.b is completed, right? Then afterwards, you have obj.c. When I say obj.c, cursor goes to your C method, printing the value of this one. Is that point clear? So this is how it executes this one. Now, this is enough actually to call all the methods. But what I want to do is, I want to make you understand how you're going to create object for abstract class, right? So base is an abstract class. So I'm going to create object base obj1. You can't create obj one more time. Object can be created only for once. So base obj1 equals to, we are going to just reference the memory. You're going to refer the memory of your derived class object to base class object. You can see this obj is object of your derived class. What you're doing, just you're referencing it to obj1. It means that what all the points or what all the things properties there in this obj will be copied into obj1. So this is called as reference object. Now here comes the picture. Right, I'm going to derive obj1 here in this way. Right, so what all the things are there in obj? Obj consists of A, B, C. Now all things are copied into your obj1. It means that A, B, C should be copied into obj1. But what happens is, it is not going to copy like that. Only the properties related to base class will be copied from obj1. So in base class, you can see you have A method as well as B method. So now from this object, A method and B method only will be copied into this obj1, A method as well as B method. Is that point clear? That's the reason why I've called obj1.a, obj1.b. Now that is one way of creating a reference object. One more way of creating a reference object is, you're going to create base obj2 equals to new. You can't say base because base is an abstract class where you can't create dynamic memory location for that, right? So base obj2 equals to new derived, you're going to say you're creating dynamic memory location for derived class using new keyword. That whatever the memory you have created, that you are assigning to obj2. Now, what all the things are there in this derived will be copied into obj2, but based on the criteria that only the contents of related to that abstract class will be copied into obj2. So now obj2 also consists of A method as well as B method. Right. Now I can say obj1.a, obj1.b, obj2.a, obj2.b. So this is how you're going to create an abstract class. This is an abstract class as well as abstract method. Right. This is an example program for that. Hope this is clear for you. And next topic we are going to learn is all about interfaces. What is an interface? Okay. Right. So interface is a collection of pure abstract methods and static final instance variables. Is that point clear? Yes. So generally, abstract class is a collection of abstract methods, concrete methods, constructors, right? Whereas interface is collection of pure abstract methods. Okay. So pure abstract methods are nothing but they consist of only prototypes, right? Function calls. But whereas its definition should be derived at your derived class. Is that point clear? And finally, you're going to have the final instance variables. Okay. It consists of final instance variables where you're going to create int a equals to some 20, where you're going to create a variable at the same time you're going to assign the value, and if you create this variable with final, this value cannot be modified in the complete program. There are some cases where you're going to take a value 20. After some executions, you're going to say a equals to 30. Now a value will be overridden with 30. And if I say a equals to 100, it will be overridden. 30 will be overridden by 100. You can change the values wherever it is necessary if that is your normal variable. But if that is a final variable, you can't change. Once the value is assigned, that value cannot be changed. Okay, that we have seen in the with the help of final keyword, right? In the previous what is that? The class. Now, the main thing is in interface, you are going to see only pure abstract methods. No other methods are possible, right? There is an advantage of interfaces. What is an advantage of interface generally? It supports to implement the concept of multiple inheritance that we have seen in the first class, that Java does not support multiple inheritance because you are going to have multiple base classes like this. Base class 1, base class 2, followed by derived class. Okay. So base 1, base 2, this is derived class. Right. So multiple base classes is not supported in Java because for every class, dot class file will be generated, dot batch file will be generated, dot what is that exe file will be generated, dot run will be generated, okay, and a dot obj file will be generated. So for every class, Java generates all these dot files. Is that point clear? So creating multiple base classes will create a sort of confusion. That's the reason this multiple inheritance is not supported in terms of Java, but they can be supported with the help of interfaces. So why? Because for every interface you create, a separate dot class file will be created. For interface also, as dot class file will be created for your normal class, in the same way for interface also dot class file will be generated, which in terms, okay, equal to that of your abstract class or normal class, right? So now this is a syntax. Interface name. Now you can see access specifier, return type, method one, list of parameters you're going to use with semicolon. This is very important. Semicolon, which is nothing but prototype. Okay, in the same way, you have one more access specifier with a return type, method two, list of parameters with semicolon. In this way, you can enclose n number of abstract methods. Okay, in the same way, you can see access specifier, data type, instance variable equals to value. You are going to create public access specifier followed by data type is int, okay, or void, whatever it is, instance variable a equals to some 10. You are defining a variable and assigning the value then and there itself. So in this way, you're going to take two, what is that instant, not only two, you can take any number of final instance variables. Okay. So now to define the methods which are placed at interface in a class should be attached with a keyword called implements. So in order to see, suppose I have a class called sample and I have interface S1 and S2. Now using implements keyword, you are going to say S1 comma S2. Is that point clear? So you're going to use a keyword called implements. Okay. Now you can see the syntax for this: class name, implements, interface one, interface two, interface three, n number of interfaces you can take. Then you have static instance variables, final instance variables, methods, static methods, because this class is not the interface, right? So you can write anything in this. Clear? Now, before working with the program of interface, let us learn clearly what are the points to be followed to work with interfaces. In terms of abstract class, you are going to use abstract as a keyword, right? Whereas in terms of interface, you're going to use a keyword called interface. Okay. By default, instance variables enclosed at interface are static and final. So if I take the final instance variables, you can see here, generally, if I take int a equals to some 10, and somewhere in the program, I'm going to take a equals to 30. Now this 10 will be overridden with 30, and somewhere I've taken a value as 40. Now this value 30 will be overridden by 40. So this is normal instance variable where you can change the values wherever it is required, right? Whereas if you declare a variable with final keyword, right? If a variable is with final int a equals to 10, and somewhere in the program, if you try to modify this a equals to 100, it is going to be invalid because the value which is given using final keyword that is finalized. It can't be modified. So this interfaces uses static and final instance variables. Now, interfaces can be implemented at more than one class. So we have n number of classes. So for n number of classes, these interfaces can be implemented. Like it can be implemented at base class, it can be implemented to derived class, and if it is a concept of inheritance like hierarchical inheritance or multi-level inheritance. So for multiple classes, you can implement this interface. So when methods are enclosed at interface, what you're going to do is only prototype or method signature you're going to write. As you have discussed with abstract method, the same thing. You're going to just write the prototype and method signature. But whereas its definition should be derived or definition should be written at derived class. Is that point clear? So that is clear here. Definition of the methods enclosed at interface should be at a class where the interface is implemented. So generally we'll implement a interface at a derived class. So you're going to write the definitions of these prototypes at a derived class, right? So for every interface, compiler creates .class file. So we know that whenever a class is created, suppose I'm going to create a class by name add, right? So internally, it generates 5 files. First one is add.class file, .obj file, then .exe file, then .batch file. Last but not least is .run file. Is that point clear? So all these 5 files will be generated for a class, whereas for interface, for every interface, .class file is generated. As this is common feature where .class file is generated for class as well as .class file is generated for interface, the common criteria is taken, and this interface is also considered indirectly as a class. Okay. Now interfaces can be extended. So if I take a class and interface, you're going to use the keyword called implements, right? And if I take class and class, you're going to use a keyword called extends. Base class, extends, derived class, right? So here, base class implements interface. In the same way, if you take two interfaces, interface 1 and interface 2, these two interfaces can also be extended. Interfaces can be extended, but they are not implemented. Whereas class and interfaces combination, you're going to use a keyword called implements. Okay. Now, in the same way as we have done with our abstract class, you are going to create only reference object, right? Which means object with dynamic memory is not allowed. The same concept. You're not going to create a dynamic memory allocation for the object of your interface. Is that point clear? So you can't use new keyword for interface. Now, reference object of interface through derived class object can access only the properties of interface. So if I create a reference object for interface, that reference object will access only the properties of interface, but not all the properties of classes and interfaces. Is that point clear? So now methods derived at derived class cannot be with private access specifier because private of base class never gets accessed at derived class. So the methods always should be created with either public or protected, but not with private. Is that point clear? Now, we are going to come across one of the example, which is very, very important, how we are going to implement the concept of multiple inheritance using interfaces, right? This is interview question, as well as this is one of the long answer question for your external expected, right? So what I'm going to do, just see here. First, I've created interface. As interface is created with a keyword called interface, and my interface name is S1. So you can create interface name of your own. Your name you can create, right? So interface, and now in that interface, I'm creating a public method, right? One abstract method, because interface is a collection of pure abstract methods. So this is one way of creating abstract method by creating a keyword called abstract, or directly you can write in this way, public void X with prototype. So if you specify prototype indirectly or directly, it means that this is an abstract method because you have created only the prototype, but definition you have not derived here. Is that point clear? So this is first interface. Now S1 consists of, S1 is an interface which consists of X method. In the same way, S2 is one more interface. You can see here, And here also I'm declaring a public void y, which is an abstract method with a prototype. So this S2 consists of y. Now S1 interface is completed, S2 interface is completed. I'm creating a derived class INF implements two interfaces, S1 comma S2. As there is a combination of class and interfaces, you're going to use a keyword called implements, right? If it is class and class, then you're going to use extends. If it is interface and interface, you're going to use extends. But it is class and interface, so you're going to use implements, right? So what I have done here. So in this class, derived class, whatever the function call is there in S1, I'm just creating a definition for it. So I'm just printing it out as message from abstract method of interface S1. In the same way, I'm defining your public void y message from abstract method of your interface S2, right? And this is normal method of your derived class INF, where you're just printing message from general method. Okay, and you have closed this. This part is very important. This is main function. INTF is a class where you have created a main function, right? So now you can create object with dynamic memory allocation for this INF, because INF is not a interface, it's a class. So class can be created with the new keyword or dynamic memory location, right? So now this object is object for your INF. Now this INF has capacity, or it can access the properties of INF, properties of S1, properties of S2. So I'm going to write here INF. So in this INF, we have X method from S1 as it is implementing S1, and we have Y method. Okay. And also we have this Z method declared. So all these three methods are present in this. Is that point clear? Now, as three methods are present in this, I can call these three methods with the help of object. So I can say obj.x, obj.y, obj.z. This is enough actually, right? But I want to show you how you are going to create a reference object for interface. So this is one way of creating it. How you're going to create? See, you're going to create S1 for interface obj1. So object is already created. You can't create object with same name, right? Multiple objects cannot be created with same name. So I need to create one more object, obj1 equals to, what I'm doing is I'm referencing the object, right? Memory of your, what is that, class, to the object of interface. So what all the things there in this obj will be copied into obj1 based on a condition that only the properties related to S1 will be copied into obj1. So if I create obj1 here, okay, this obj1 consists of all the things are copied from obj to obj1. So in obj, this is INF object, right? Because you have created object for INF. So this is obj. It has X method, Y method, and Z method. It has to copy all these methods into your obj1, because you're saying obj1 equals to obj. But what happens is it is not going to copy all the things, but only the properties related to S1 will be copied from obj to obj1. So what are the properties of S1? Only X. So X method will be copied into your obj1. Only X method, right? So I can call obj1.x. In the same way, S2 obj2 equals to obj. Again, obj2 will be created in this way, and object, you're copying the properties of object to obj2. So all the things, all these methods should be copied. But as this is object of your S2, the properties related to S2 will be copied into your obj2. So what are the properties of S2? S2 have only Y method. So Y method from this obj will be copied into obj2. So Y method. So that's what I'm calling obj.y. Is that point clear? So this is how you're going to create reference objects. Now it is very much clear that, see, you are implementing two interfaces. What is the concept of multiple inheritance? You're going to have multiple base classes followed by one derived class. So I'm going to take here base 1, base 2, and this is derived. Okay. So as multiple base classes are not allowed in Java, right? Instead of these base classes, we are taking the concept of interfaces. So instead of B1, you're going to have S1. Instead of B2, you're going to have S2, right? So now this S1 and S2 are implemented to your derived class, that is INF. So indirectly or directly, these two are your base classes S1 and S2. As you're implementing them, right? So you're implementing multiple base classes, which in turn supports the concept of multiple inheritance in Java. Is that point clear? So in this way, implements S1, S2, you can take S3, S4, S5, how many interfaces you want, you can take. Is that point clear? So this is the concept of illustrating multiple inheritances, multiple inheritance using interfaces. Hope this is clear. So in the next class, what we are going to learn is the last topic of your second unit, that is packages. Right. So very, very important points we're going to cover in this. What is a package? First question. Second question, how we are going to create a class path for the package, and what are the points to be remembered to work with these packages, and how what all the things, like how many classes you're going to create in package, right? So to start with, I'll just brief you. Packages are nothing but collection of, right? It's a collection of dot class files and sub packages. Is that point clear? So package is a collection of dot class files and sub packages. What is the major advantage of using packages is it avoids collision of dot class files. It avoids collision of dot class files. What is the meaning of this? Suppose I have created one class called add dot class, right, with some logic in it, and another person, or maybe am right, I have created one more add class with another logic one, right? So after closing the system, when I start again, if I want this logic one program, if I say add dot class, what happens is this add dot class data will be overridden. There will be a collision between these two dot class files. You can't create dot class files or classes with same names because they'll be overridden. So in order to avoid such collision of dot class files, you have been given with the concept of package. So what I'll do is I'm going to create a package. Okay. Package by name, whatever it is, Java, right? I'm going to create package Java. Okay. In that package, I'm going to create add. So one class is created inside the package, another class is created outside the package. So if I want to access this, I'll go inside this package and I'll call a class add. So this class inside the package will be accessed. And if I don't go into the package and if I ask just add, so this add will be created. So this add class will be called, which is not inside the package. So now there is no confusion, right? One add class is inside the package, another add class is outside the package. So there is clear differentiation between these two dot class files. So there is no chance of any collision. So these concepts that we are going to learn in the next class, right? Don't miss this class. Packages, very, very important. Long answer question as well as interview point. It is very important. Okay. Thanks all.